it involves numbers. But there is a difference between this question here, 4.7, and the question on page 1 here. The difference is the angle. The angle given here is the angle with the vertical. Can you see the theta is the angle with the vertical line here? Can you see that the angle theta is the angle with the vertical line here? But if you look at this example on the second page, different. No? The angle is with the horizontal line. Earlier on, it is this angle that is
Yeah,
given,
okay.
this angle, right? But
Uh-huh.
now it is the angle with the horizontal. It doesn't matter. The cos theta and sine theta, they interchange. That's all, right? So nothing to worry about. Only difference is they interchange the sine theta and cos theta. Okay, so now let you read the question first. 4.7, example 4.7.
A traffic light weighing 1 times 10 to the power 2 Newton hangs from a vertical cable tied to 2 other cables that are fastened to a support as figured in 4.31a. The upper cable makes an angle of 37 degrees and 53 degrees with a horizontal. Find the tension in each of the 3 cables.
Okay, now actually they give you this angle here. They give you this angle here. You cannot know whether it's angle with the horizontal or vertical. So we draw a horizontal line. A horizontal line. You see that these two angles, they are alternate angle. In mathematics, we call them alternate angle. Alternate angle means the two angles that are the same. This angle here and this angle here. Can you see the Z here? Like that. Then there's a Z. There's a Z here. Like that. So these two angles, they are alternate angles. So this angle here is also 37. Similarly, if you look at this angle 53 degrees, the alternate angle is this angle here, is also 53 degrees. How do we know it's 53 degrees? You see the Z here. The Z here shows that they are alternate angles. So the alternate angles, they are equal. Okay or not? So the angle
Yep.
here is actually angle with the horizontal. Okay, so I clear off this. So it is drawn on the right hand side here, right? The the diagram, the force diagram is here. Before we go on to the force diagram, what is actually happening here is traffic light. Okay, a traffic light is hang with a rope of T3. The T3 rope number 3 hangs the traffic light vertically. Now this rope number 3 is tied at the point here with two other ropes. The rope number 1, which produce a tension of T1, and rope number 2, which produce a tension of T2. So when we look at the force diagram, the T1, the T2, and the T3, they are the three forces acting at this point here. And these three forces, they balance one another. You don't look at the traffic light. You look at the point of equilibrium, the black dot here. Right? The black dot is from where the forces, they branch out. Okay, so three forces branch out from this black dot here. So we look at this black dot. Since this black dot is not moving up, down, or sideways, so the three forces, they are at equilibrium. The three forces, they balance one another. The net force is 0. Okay. We look at this T3 here. This T3 is actually produced by the weight of the traffic light. So you look at this diagram at the center here. Hello? Ah, 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 chậm dịch chấm hả? Ok, ok. Ah, okay. So where are we now? Okay. So if you look at the T3, T3 is actually produced by hanging the traffic light onto the rope here, tied to the rope here. So
Mm-hmm.
if you look at the traffic light, there are two forces acting on the traffic light. T3, which is pulling the traffic light upwards, and the weight of the traffic light, 100 Newton, which is pulling the object downward. So we conclude that the T3 must be equal to the weight of the object. So when we look at the force diagram, okay, we consider this T3 known. It is equals to the weight of the object. So we shift on to the last diagram here, which is the force diagram. The force diagram shows three forces acting on this point where the three ropes they are tied. So T1, which is an angle of, at an angle of 37 degrees with the horizontal. T2 produced by rope number 2, which is at an angle of 53 degrees with the horizontal. And T3, which is acting vertically downwards. Now, why is it acting vertically downwards? Because it is produced by the weight of the traffic light. So in the next part, I'm going to resolve this T1 and T2 into their components. Okay, so let us consider this T1 here. Okay, so I've drawn the T1 here. Right? I've drawn the T1 here. And this T1 is acting at an angle of 37 degrees with the horizontal. This angle is 37 degrees, the angle here, right? The angle here is 37 degrees. And if I resolve them into their components, the horizontal component, is now adjacent to the angle. So this horizontal component must be cos theta, and the theta is 37 degrees. So the horizontal component is T1 cos 37 degrees. If we look at the vertical component, the vertical component is not adjacent to the given angle. Or this is not the given angle. This one is the given angle. So if it is not adjacent to the given angle, so this component is T1 sine 37 degrees. T1 sine 37 degrees. Okay. Now we look at the T2, the tension in rope number 2. This T2, it makes an angle of 53 degrees with the horizontal. This is the 53 degrees. This is 53 degrees. So this is the angle 53 degrees. The horizontal component is adjacent to this angle. So you have to label it cos. So the horizontal component is T2 cos 53. T2 cos 53. The vertical component is not adjacent to the angle. The vertical component is T2 sine 53 degrees. Okay, so the two forces, the two red arrow, I have resolved them into their respective components, their respective vertical and horizontal components. So when you resolve them, they no longer exist. You are actually replacing them with the blue arrows. So I close the red arrow and I just look at the blue arrows. So how many arrows are there altogether? 1, 2, 3, 4, and 5. So these 5 arrows, they are supposed to balance one another. Now I just want to look at the vertical components. The vertical components, they are T1 sine 37 and T2 sine 53. These two forces, they are balanced by the weight mg, and we know mg is 100 newtons. So we can actually form the first equation. How to form the first equation? Comparing the vertical forces. So the vertical forces, they are this one, and this one. These are the three vertical forces. So how they balance one another? T1 sine 37 plus T2 sine 53. This is equals to 100 newtons. So I keep this as equation number 1. Now I look at the horizontal component. The horizontal component. The horizontal components, they are T2 cos 53 and T1 cos 37. These are the two horizontal components. Because the object is at equilibrium, these two forces also balance one another. So when they balance one another, I say that T1 cos 53, T1 cos 37 equals to T2 cos 53. Now our aim is to find the tension T1 and T2. So I try to make T1 the subject of the formula. I move the cos 37 to the other side. So now T1 is the subject of the formula. T1 equals to T2 cos 53 divided by cos 37. So I keep this and call this equation number 2. I have to solve the two equations simultaneously to find out what is T1 and T2. How to solve them? I use equation number 2, substitute into equation number 1. Okay, so this is T1 sine 37. T1 sine 37. This one is T1. T1 sine 37 plus T2 sine 53. T2 sine 53. T2 sine 53 equals to 100. Equals to 100. So now you just take out your calculator. You calculate the cos 53 multiply with sine 53 divided by cos 37. See if you can get this number or not. 0.4535. You have your calculator with you? You try and see. Is it this number?
So with cos 33,
53 divide times cos sine 37.
cos 53 divided by sine 37,
Times
0.0. Yes?
Then divide by cos 37. What's the answer?
Yeah. Give me a sec.
How much you get?
Divided by cos 37,
Ah.
0.04.
4, 5 something. You have to get more decimal places. Is it 4535?
Yes.
Okay. So this T2 and the other one, T2 sine 53. Sine 53, is it 7986?
Yes.
Okay. So we add these two tensions together because both of them, they are T2, so they can be added together. So when you add them together, the answer is 1.252. 1.252 T2, and you bring the 1.252 over 100 divided by 1.252, answer is 79.9 newtons. So actually we can solve and find the tension T2. To find the tension T1, you have to substitute this answer back into equation number 2. So when you substitute into equation number 2, T2 you replace with 79.9. The other trigonometric ratio, they remain the same. So you use 79.9 multiply with the trigonometric ratio, you get 60.1. So this is tension in the rope or string number 1. Rope, because this one quite heavy, the traffic light. So these are the tensions in the rope. Cable, they say cable. Okay, cable. Any questions so far?
No.
No question. Okay. So we look at